Hi, this video is about the Caribou Mathematics Contest. I'm going to show the solution for the January 2014 Grade 9-10 Contest, Question 20, which also came up in the Grade 11-12 Contest. So the question is, suppose that for some angles x and y, the sine of x and that squared plus the cosine of y and that squared equals 3 over 2a, and the cosine of x and that squared plus the sine of y and that squared equals 1 over 2a squared. Determine the possible value or values of a. Okay. So one formula that we will need to know for this question is that the sine of any angle x and that squared plus the cosine of that same angle x and that also squared must also always equal 1. And also this works for any angle x, so it doesn't just have to be x, it could be y too. Okay, so let's look at the question, and let's look at this equation. So, looking at it at first glance, you would think that you could use the formula for this equation, but if you look closer, you can see that it is the sine of x and that squared plus the cosine of y instead of x and that squared. So we cannot use it yet. But if we look at the second equation and the left-hand side, we can see that that matches perfectly because, again, for the formula, it doesn't matter if it's x or y. It still works. So we will now add up the left-hand sides of the two equations, and therefore we will have the sine of x and that squared plus the cosine of x and that squared, which we know is 1. And then we have the sine of y and that squared plus the cosine of y and that squared, and we know that is 1. So we have 1 plus 1. And then adding up the right-hand sides, we have 3 over 2a plus 1 over 2a squared. Okay, so now to simplify this, to get rid of the halves, we will multiply both sides by 2. So we know that this is 2, so this becomes 4. So we have 4 equals 3a plus a squared. So to get this to equal 0, we will just have a squared plus the 3a. And then since we have 2 times 2 is 4, and putting on the other side we have minus 4, and on the other side we are left with 0. So we know that this is a quadratic equation. So now we will use the formula. So to solve for a, we will have a equals, and now we will take 2 times the coefficient of a squared, which is just 1 because it's 1 times a squared, and 2 times 1 is 2, so we have over 2. And then now we have minus the coefficient of a, which is 3, so minus 3. And then we have plus or minus, and then the square root of the coefficient of a, which is 3, and that's squared, so 3 squared is 9. And then we would take minus 4 times coefficient of a squared, which is just 1, so we have minus 4 times minus 4 is 16, so we have plus 16. Okay. So we know that 9 plus 16 is 25, and we know that the square root of 25 is 5. So we are left with still 2 at the bottom. Then we have minus 3. And again we have plus or minus. And then 5, because the square root of 25 is 5. So for the first case we will add 5. So we have minus 3 plus 5 is 2. Over 2 is 1. And then, now if we subtract 5, we have minus 3 minus 5 is minus 8. Over 2 is minus 4. So for now, A equals either 1 or minus 4. So now let's look at the question again. So now we will look at this equation only. So since we know that this is a square because it is a sine of x and that's squared, so we know that this must be either 0 or positive. And then we have plus another square because we have the cosine of y and that squared. So we have either 0 or a positive number plus 0 or a positive number equals, so we know that the sum must also be either 0 or positive. So since we already have 3 over 2, which is positive, and we have times a, we know that a must be positive. And since for our two answers here we have a equals 1 and minus 4, we know that minus 4 is not positive, we know it is negative. So therefore we know that a equals 1 is the answer. So we know that the answer is 1. If you'd like to know more about this contest, please feel free to visit our website at www.brocky.ca/caribou.